Hello student, hi, good evening. So this is our question number 60, okay, ISRO 2018, question set C, okay, question number 60. So asking a monostatic pulse radar operating at a frequency of, there is a monostatic pulse radar which is operating at a frequency of what? Frequency of 30 gigahertz. What? 30 gigahertz. Operating at the frequency of 30 gigahertz and has a transmitter with what? With output power which is transmitted at 2 kilowatt. Oh, yes, 2 kilowatt. And it has a transmitting antenna which is transmitting the power of 2 kilowatt. 2 kilowatt. This is my output power. What? Output power. Okay. So now, and an antenna with 30 dB gain. So this transmitting antenna has gain of what? Gain of 30 dB. What? 30 dB. So gain of 30 dB. Okay. So gain of 30 dB. So the minimum detectable signal in the receiver is what? Minimum detectable signal in the receiver is nothing but that is minimum detectable signal P received signal. So that is how much? Minus 100 dBm. Minus 100 dBm. So now determine the maximum range of the radar. And he is asking what about maximum range of radar? What is the maximum range of the radar? If it is required to detect the target having the radar cross section, okay. If it is what? If it is required to detect the target having the what? Having the radar cross sectional area. How much is there? Radar cross sectional area is nothing but that is 10 square centimeter. Yes, 10 square centimeter. 10 meters square. This is what? Radar cross sectional area. Okay. So and assume that FM wave propagated under ideal condition. Okay. So FM wave is propagated under ideal condition and is asking about maximum range. See here, this is my what? This is my transmitting antenna. Yes. So transmitting antenna of what? Radar. Okay. Similarly, there is what? There is receiving antenna of what? Receiving antenna. Transmitting antenna, receiving antenna of radar. Yes, radar. Transmitting and receiving antenna of radar. Yes, transmitting and receiving antenna of radar. Yes, this is my transmitting station. So this is at transmitter side. Yes, transmitting station. This is my transmitting station. Yes, transmitting station. So now here let us assume there is a one plane. Yes, so this is my target. Here is the target. Okay, somewhere is my, here is my what? Target. Okay, so target. So let us say this is what? Helicopter. Okay, so now this is a target. Yes, so this is my transmitting antenna. This is transmitting antenna and this is my receiving antenna. Receiving antenna. Yes, this is my receiving antenna. This is receiver station. This is transmitter and receiver. Trans receiver. This is nothing but trans receiver. Okay, trans receiver. So this is my transmitting antenna, receiving antenna. So transmitting antenna, receiving antenna, and this transmitting antenna is what? Radiating the power. Radiating the power. Yes, radiating the power of what? PT. Power of PT in the form of electromagnetic wave. Okay, FM wave. So now electromagnetic wave. So now when this power. So let us assume what? Let us assume that the gain. Let us assume that the antenna. Okay, antenna of this transmitter is what? Isotropic antenna. Yes, isotropic antenna. Isotropic antenna means which is what? Which is uniformly radiated in all the direction. Uniformly radiated all the direction. Or as we know very well, the gain of what? Isotropic antenna. Gain of isotropic antenna is what? Antenna is unity. Yes, gain of isotropic antenna is nothing but unity. But the gain is what? Gain is given as what? Given as 30 dB. So we cannot say that it is perfectly isotropic antenna. So but somewhat the power is what? Power is aligned in one particular direction. The power is aligned at one particular direction toward what? Toward this target. Okay. So toward this target. So now this power is what? This power is radiated. Okay. So now let us say the power is what? Let us say I am saying that my power here is what? Here is PT. So PT with the gain of what? PT. Okay. So this is my transmitting power PT. Okay. So now what is the power density? What is the power density? Power density is nothing but PT upon this whole area. This is what? Surface area. Let us say this is our earth. Yes, this is what whole earth. Okay, what is the surface area? Surface area, this is a spherical, so means surface area is nothing but 4 pi r square. 4 pi r square. Okay, so this is my what power density, means power per unit area. Power per unit area. Okay, so then after that if you see, this is my what, this is my power density. Yes, power density. So after that power density. Okay, so now the power density with what, with gain. So also the transmitting antenna is what, transmitting antenna is radiating the power in some particular direction. Okay, so it is aligned in some particular direction with the gain of what, with the gain of 30 dBm. Yes, with the gain of 30 dB. So therefore we can say that power density is equal to what, PT GT divided by 4 pi divided by 4 pi r square. 4 pi r square. Okay, so 4 pi r square. Just wait. Yes, this is what, PT GT divided by 4 pi r square. Yes, 4 pi r square. Yes, GT is what? GT is what? Transmitting gain of transmitter. Transmitting gain of an antenna or transmitter. Okay, so this is what? This is my power density. This is my power density. Now this power density. Yes, so this power is what, radiated. What, toward this target. Toward this target. Okay, so now when this power will come to this, toward this what, target, then some of the power will get reflected. Okay, so this reflected power is here. Okay, so this is my, let us say this is my reflected power. Yes, reflected power, REPREA. Yes, reflected power. This reflected power will get received by receiver. Okay, receiver of what, receiver of radar. Okay, so receiver of radar. So now receiving antenna, so this power, reflected power, will get received by this receiving antenna. How much is this reflected power? First of all we will calculate this. Reflected power is nothing but, see, reflected power is nothing but p reflected power is equal to, now this P reflected power is nothing but, let us say when the power is transmitting, power is transmitting from transmitter to this target. Okay, now let us assume that this target has cross sectional area. Okay, so cross sectional area of this target is like sigma. Okay? So this is what, radar cross sectional area. So this is what, this is my target, and this target has cross sectional, radar cross sectional area of, radar cross section area is how much, sigma. So this is like a footprint. Okay, footprint means something like this light is coming. Okay, so it is capturing some particular area. That area is nothing but over, that area is nothing but cross sectional area. Okay, so this is what, like radar cross sectional area of what, target. So this is my radar cross sectional area. Okay, so now this reflected power is nothing but, PD into sigma. Yes, PD into sigma is equal to what, PD into sigma. So which is nothing but nothing but PT GT sigma by sigma by 4 pi r square. 4 pi r square. Okay, 4 pi r square. This is my reflective power. What, reflective power? Reflected power is nothing but, this is the power of echo signal. Because whatever the power is going, it is very large in the order of kilowatt, and whatever the power that will get received by this receiving antenna is in the order of what, is in the order of nanowatt or picowatt. So therefore nanowatt or picowatt. Why? Because see here, this is my reflective power. Because this reflective power is just a echo signal. Yes, echo signal means reflected power. Reflected power in the form of echo signal, and this echo signal has power PRF, reflected power. This reflected power is nothing but power of echo signal. That is what, that is reflecting toward the radar receiver. Okay, so now similarly, as we have assumed here that, as assume that here that the isotropic antenna means transmitting antenna, we are assuming here as a isotropic antenna. Okay, isotropic antenna as a basis to understand. Okay, so as basic, it is not actually isotropic antenna, because this power is radiated to in one particular direction. It is aligned some particular direction with the gain of 30 dB. Okay, so similarly we will take in the case of what, reflected power. So let us let us say that this reflective power is what? This reflective power here this what this target. Okay, so target. We are assuming this target. Yes. So here also it has what? Isotropic. Okay, so means whatever the power is reflected from this target is we are assuming it as a isotropic. Okay, isotropic nothing means the power is radiating uniformly in all the direction. Okay, so all the direction. And here is what transmitting antenna, which is transmitting its power uniformly all the direction. This is just we are taking as a basis to understand. Yes. So similarly here. Okay, so why we are taking this? Because we want to find here reflective power density, like reflective power density, like transmitting power density, like this transmitting power density. Here also we want to calculate reflective power density, and this reflective power density is also reflected over the surface area, means per unit area. So then what is this reflective power? If you see reflective power density is nothing but p reflected power. Yes, p reflected power upon surface area. How much? 4 pi r square. 4 pi r square. Okay, so surface area 4 pi r square. Now, so up to this, it is clear. Okay, it is clear to all of you. Why? Because as we have seen there that as that power is transmitting from the transmitter side, okay, toward the target. First, we assume that the power is Pt. This power is Pt, and this power is radiating over the surface area per unit area. Area is what? Area is what? Surface area. That is 4 pi r square. Okay. So then after that, what we have seen? Power density. What? Power density. So we have we have taken the, and here it is given that what? The transmitting gain of an antenna is gt. So therefore power density is equal to pt gt, power density with gain. Okay, with transmitting gain, because this power is transmitting at particular direction, not uniformly, not at all the direction, in particular direction with a transmitting gain of 30 dB. So this is what pd is equal to pt gt by 4 pi r square. 4 pi r square. So after that, similarly in this case, p reflective power is nothing but p reflective power upon 4 pi r square. P reflective power density means reflective power per unit area. Area here is what? Surface area of the earth. So now let us say I'm going to rub this. Okay, so here, so up to this is clear. Okay, so now we will go further up to what we have reached. This is what p reflected power density. Yes, p reflected power density is nothing but p reflected power upon 4 pi r square. 4 pi r square. As we have calculated what p reflected power is nothing but pt gt is sigma divided by 4 pi r square. 4 pi r square. So this is my what? This is my reflected power. Okay, reflected power per unit area. It will give us what? Power. This reflected power density. This is what? 4 pi r square per unit area. So therefore total reflected power density is nothing but this is pt gt sigma by 4 pi r square. 4 pi r square whole square. Yes, whole square. So this is my what? Total reflected power density. So now see here pt gt sigma divided by what? 4 pi to the power 4 into r to the power 4. Okay, r to the power 4. So this is my transmitting power. This is my gain of transmitting antenna, and this sigma is nothing but here it is cross sectional area of what? Target. Radar cross sectional area of a target. Okay, so this is r is the distance. This is what? Maximum range from the radar to what? Radar to target. Okay, so now radar to target. So now what is the reflective power? That reflective power density. This is my p reflected power density. Yes, so this is what? This power is reflected toward what? Receiver. Okay, so toward receiving antenna. Okay, so toward receiving antenna. So now this receiving antenna has power PR, with what effective aperture area, of what AE. Okay, so effective aperture area of receiving antenna is AE. Okay, so AE. So therefore, received power is what? Received power by what? Radar. Okay, through the receiving antenna is equal to what? PR is equal to P reflected power P reflected power density into effective aperture area of what? Effective aperture area of a receiver. Okay, area of a receiving antenna. Now, what is this effective aperture area of receiving antenna? See, effective aperture area of receiving antenna. This is nothing but lambda square by 4 pi, into gr. Yes, so this is my effective aperture area, of receiving antenna. Okay, so gr is what? Gr is the receiving antenna, gain of receiving antenna. Lambda is the wavelength. Okay, so now just put this effective aperture area value into this. Okay, into this equation. This is what? P received power. P received power is equal to P reflected power density, which is nothing but PT GT sigma divided by, okay, PT GT sigma divided by 4 pi 4 to the power 4 into R to the power 4 into effective aperture area is nothing but lambda square divided by 4 pi. Yes, just wait. Effective aperture area. Yes, okay. So this is what? 4 pi. This is what? Square. Okay. So this is my square, not 4. This is square. Okay. This is square. So that's why I am confusing. I got confused with that how it is coming 4. Okay. So now see, this is what? Lambda square by 4 pi. Into 4 pi into gr. Okay. So now gr. So this is what? P received power. By what? By receiving antenna. Is how much? If you see, how much is this? PT GT, GR, PT GT, GR, sigma, lambda square divided by 4 pi, whole cube into R to the power 4. So this is my what? This is my received power by an antenna, receiving antenna. Received power by an receiving antenna. Okay, so this we have reached our final destination. Okay, so now we will just put the value and we will get the answer for this. Okay, so now we will see. So let me remove this first. Okay, so that is, see, let us put all this value. So this is what? R, yes, R to the power 4. So this is what? R to the power 4 is equal to what? This is P received power. P received power is what? Minimum detectable signal, which is a echo signal. Okay, this P received power is nothing but it is a minimum detectable signal, which is nothing but echo signal, which is reflected by the target, So this is R to the power 4 is equal to what? Is equal to PT GT, GR into sigma lambda square divided by how much? 4 pi cube into S minimum. Yes, S minimum. Why? Because this received power is nothing but it is the minimum detectable signal, which is nothing but echo signal that is reflected by the radar. Okay, so now see here. So let us calculate this lambda first. Okay, so what is my lambda? Lambda is nothing but C by F. C is what? 3 into 10 to the power 8 divided by frequency is what? What is the frequency? 30 gigahertz. So 3 into 10 to the power 10 to the power 10, which is nothing but 1 centimeter. Okay, so this is my lambda wavelength. Yes, wavelength of what? Signal. So wavelength of signal is 1 centimeter. Yes. So and this GTGR and GTGR is how much? GTGR is nothing but it is 30 dB, 30 dB. When we are taking the power in dB, then this power will get added. Okay, so power in dB will get added if it is product. Okay, product if it is product. So this is what 30 plus 30, 30 plus 30 dB. dB. Okay, so product signal that will get add in dB. Product signal will get add in dB. So which is nothing but 60 dB. What 60 dB? Okay, so this 60 dB is nothing but 10 to the power 60 by 6, 60 by 6 watt. Yes, 60 by 6. Okay, so this is what gain. There is no unit for this gain. Okay, so 10 to the power 60 by 6, which is nothing but 1 into 10 to the power 6. Yes, this is what GTGR. Okay, so GTGR and minimum detectable signal. Detectable signal that is given as what 100 dB. What 100 dBm. This is given as 100 dBm. How much is this? 100 dBm is nothing but if you see 100 dBm, 100 dBm. So 100 dBm is equal to 10 log. What 10 log? 10 log minimum detectable signal is S minimum divided by 10 to the power minus 3. Yes, minus 3. So this will go this side and this is what detectable signal and dBm. Okay, so S minimum. So this is, I think so, this is what minus 100. This is minus 100 dBm. Yes, minimum detectable signal. This is minus 100 dBm. So I think so. This is minus 100 dBm. Yes, this is minus 100 dBm. So this will get what here. If we see minus 10, minus 10. Yes, minus 10 log, minus 10 log S minimum divided by 10 to the power minus 3. Yes, so minus 3. Then here S minimum signal is nothing but this log will go here and it will come 10 to the power minus 10 into 10 to the power minus 3 watt. Yes, 3 watt. So S minimum here is what? S minimum is nothing but 1 into 10 to the power minus 13 watt. 13 watt. Yes, so S minimum is nothing but S minimum is nothing but S minimum is nothing but zero point 0.1 picowatt. 0.1 picowatt of power. Yes, 0.1 picowatt of power. So this is my detectable signal by radar receiver. By radar receiver. Okay, so radar receiver. Now let us see. Receive the power. Now plug all these value into this radar range equation. So that is what R to the power 4 is equal to. How much is PT? That is 2 kilowatt. 2 into 10 to the power 3 into what is GTGR? GTGR is nothing but 10 to the power 6 into what is sigma? Sigma is given as 10 meter square. Okay, so 10 into what is lambda is 1 centimeter. That is 10 to the power minus 4 divided by 4 pi 4 pi cube into S minimum is what 0.1 picowatt means 10 to the power minus 30. 10 to the power minus 30. So this is my what range R to the power 4. Okay, R to the power 4. So now let us solve this. What we will get here? If you will see here 10, 6, 3, 9, 9, 10. Yes, 10 minus 4, 6. 6. 10 minus 4 is plus 6. Yes, plus 6. So plus 6, this 13 will go up. So that is 10 to the power 9. Yes, so this is what, if we see here. So R to the power 4 is equal to, R to the power 4 is equal to 2. 2 into 10 to the power, 2 into 10 to the power. See here, 6, 9, 10, 10, 6. This is plus 13, 90. 90. Okay, so 90 divided by 4 pi whole cube. 4 pi whole cube. So we can write R to the power 4 is equal to 0.2 into 10 to the power 20. 10 to the power 20 divided by 4 pi. 4 pi whole cube, 4 pi whole cube. Okay, so now here point 2, what we will do here, 1 into 1 into 10 to the power 20 divided by point 2 will come down. Okay, so let us take it down. So that is 5 into 4 pi, 4 pi whole cube. Yes, whole cube. So this is what 1 by 4. Yes, r is equal to, this is what power is 1 by 4. Power is 1 by 4. R is equal to this. Yes. Now here r is equal to what? 1 by 5. So if you will see here, 1 by 5 into 4 pi whole cube is nothing but 320 pi cube. 320 pi cube into 10 to the power 10 to the power 20 means 5. When you will solve this, what we will get here, we will get 1 by 320 pi cube means it is just 1 into 10 to the power minus 4, just 320 pi cube. Yes, 320 pi cube. Here also, here power is what? In this power is what? Power is 1 by 4. Power is 1 by 4. So this is nothing but, when you will solve this, we will get 1 into 10 to the power minus 4. Okay, 1 by 4. So into 10 to the power 5. So which is nothing but 0.1 into 10 to the power 4 meter. Yes, 10 to the power 4 meter. So therefore you will get the radar, maximum range of radar from maximum range from radar to target is nothing but r maximum is equal to what? Is equal to 0.1. 0.1 into 10 to the power 5. Sorry. So this is 10 to the power 5. Yes, 0.1 into 10 to the power 5. So which is nothing but 10 to the power 4 meter. 4 meter, and this is what? 10 kilometer. 10 kilometer. So therefore maximum range from radar to target is what? 10 kilometer. 10 kilometer. Yes. So therefore we can say that for this option is correct. Option is correct. Okay, option is correct. So this is all about what? Radar range equation. We have seen whole derivation for radar range equation. Okay, from transmitting power to receiving power. Okay, transmitting power to receiving power. How the power is transmitted? First we had assumed what? Isotropic antenna. Okay, isotropic antenna. We have assumed the antenna of transmitter as isotropic antenna, which is radiated uniformly in all the direction per unit area. So we have taken that for what basis? In the basis of understanding. Okay, for understanding purpose we have taken that isotropic antenna. Okay, so because we want to find what? Power density per unit area. Okay, so similarly for refractive power, when this power will get transmitted toward the target, so then this power will get, okay, so this power will get refracted back, okay, in the form of echo signal, which is very small amount, in the order of picowatt. Okay, so through this we have solved all, and we have plugged all the value into this range equation, and we got the maximum range between the radar and target is 10 kilometer. Okay, 10 kilometer. So thank you for watching this. Okay, so you can understand all the derivation about this radar range equation. Okay, so actually we have done this derivation through this concept. Okay, so this concept we have understood through what? Derivation, by doing this question. Okay, so this is not only the question. Okay, so this is also the derivation for radar range equation. Okay, which you can understand properly. Okay, so line by line. So how we have done. Okay, so that's all for today.